For 65 years, one half of the moon has been staring away from us, and nobody could tell you what it was hiding. Think about that. We have mapped the ocean floors. We have photographed black holes. We have machines rolling across Mars right now. And yet, the entire far hemisphere of the object that controls our tides, stabilizes our planet, and hangs in our sky every single night remained a chemical blank, a face we had seen but never truly read. Then a machine looked at it, not a telescope, not an astronaut. An artificial intelligence fed something no human eye had ever examined, and what it pieced together did not just fill in a map. It cracked open a question about the moon that scientists have been afraid to answer out loud. Let me start with the thing almost nobody outside the field understands, because everything that follows depends on it. The moon you see at night, the friendly familiar face with its dark patches and bright highlands, is only one side. You have never, not once in your entire life, seen the other half with your own eyes. Nobody has. The moon is tidally locked to Earth, which means it turns exactly once for every orbit it makes around us, keeping one hemisphere pointed at us forever and the other pointed permanently into deep space. The first time humanity ever glimpsed that hidden hemisphere was in 1959, when a Soviet probe called Lunar 3 swung around the back and sent home a handful of grainy photographs. And when those photographs came in, the scientists looking at them went quiet, because the far side was wrong. Here is what wrong means, and this is where the mystery actually begins. The near side of the moon, the one facing us, is covered in vast, dark plains called Maria, ancient seas of hardened lava that make up roughly a third of that hemisphere. Those dark patches are what your eyes trace when you look up and imagine a face in the moon. But the far side has almost none of them. Less than 1% of the far side is covered by those lava plains. Instead, it is a brutal, mountainous, cratered wasteland, pounded by impacts, thicker, higher, and older looking than anything on the side we know. It is, in every meaningful way, a different world wearing the same name. And for decades, nobody could explain why one moon had two completely different faces. Now hold that image, because the differences run deeper than the surface. When NASA's gravity mapping mission measured the moon's crust, it found that the far side's crust is on average about 20 kilometers thicker than the near side's. 20 kilometers. That is not a minor asymmetry you can wave away. And sitting on that far side is the single largest impact structure known anywhere in the entire solar system. The South Pole Aitken Basin, a scar roughly 2,500 kilometers across and 8 kilometers deep, gouged into the crust by an ancient collision so violent it may have punched down toward the moon's mantle itself. Everything about the far side screams that something happened there, something enormous, something we were never around to witness. But without a piece of it in our hands, every explanation was just an educated guess. And that is the wall science kept slamming into. For over half a century, every theory about the far side, every model of why it's thicker, why it's drier, why it barely erupted while the near side flooded itself with lava, rested entirely on remote observation, cameras in orbit, radar bounces, gravity readings. We were reading the cover of a book we had never been allowed to open. Because in all the decades of lunar exploration, in all the missions the United States and the Soviet Union flew during the space race, not one of them ever brought back a single grain of rock from the far side. Every sample humanity possessed, every Apollo rock, every Soviet scoop of soil, came from the near side, the half we already understood. The hidden half stayed sealed. Then, in June of 2024, that seal broke. China landed a spacecraft called Chang'e 6 inside the far side's Great Basin, drilled and scooped, and did what no nation had ever done. It lifted off from the hidden hemisphere and carried a payload home, the first physical samples ever returned from the far side of the moon. Roughly 2 kilograms of soil and rock from a place no human hand had ever touched, a place that had been chemically invisible to us since the beginning of the space age. Read that again. For the first time in the history of our species, we were holding a piece of the moon's dark half in a laboratory on Earth. And the moment we did, the far side stopped being a photograph and became evidence. But here is where the story takes the turn nobody expected, and where the machine enters. Because 2 kilograms of rock from one landing site is not the same as understanding an entire hemisphere the size of a continent. You cannot walk the whole far side. You cannot drill it in 1,000 places. What the samples gave scientists was a ground truth, a single precisely measured fingerprint of what the far side is actually made of. And the question became, how do you take one perfect measurement and use it to read an entire face of the moon you'll never physically reach? That is not a problem a human can solve with a ruler and a telescope. That is a pattern recognition problem on a planetary scale. And that is exactly what artificial intelligence was built for. So researchers did something that sounds almost like science fiction, except it actually happened, and it was published in a peer-reviewed journal. They took the hard chemical data from the returned far side samples, the exact composition measured atom by atom in the lab, And they used it to train an AI model. Then they fed the trained model an enormous library of high-resolution orbital imagery covering the far side. Images captured from lunar orbit that, on their own, were just light and shadow and gray terrain. And they let the machine do what it does best: find the invisible correlations between what a place looks like from orbit and what it's actually made of on the ground. The AI learned the chemical language of the far side from the samples, and then it read that language across the entire hemisphere. What came out the other end had never existed before in human history. The machine produced the first high-precision map of the chemical makeup of the moon's far side, a detailed distribution of the major oxides and minerals across a hemisphere that had been a chemical blank slate since the dawn of astronomy. Half the moon, unmapped since the beginning of time, suddenly rendered in chemical detail by a system that had learned to see what our instruments alone could not. This wasn't a prettier picture. It was a fundamentally new kind of knowledge. The difference between seeing a stranger's face and reading their DNA. In the instant that map existed, scientists could finally test the theories they'd been arguing about for 50 years against something real. And this is where it stops being a story about a map and becomes a story about a mystery. Because when researchers analyzed the far side material, both through the AI's global map and through direct study of the samples themselves, they found the smoking gun for one of the oldest unanswered questions in planetary science. The far side of the moon didn't just look different on the surface. It was born different, deep in its interior, billions of years ago. The rocks revealed that the far side's mantle, the deep layer beneath the crust, formed from cooler magma than the near side. The hidden half of the moon appears to have been, and may still be, colder on the inside than the face we've stared at all our lives. Think about what that actually means, because it is genuinely strange. The moon is not a uniform ball of the same stuff. It is thermally lopsided, hot on one side, cool on the other, like a planet with a fever burning on only half its body. For decades, this was a hypothesis, a suspicion whispered in models, something scientists called the two-faced moon without being able to prove. The near side and the far side weren't just cosmetically different. The difference reached all the way down into the deep interior. But it was theory. Now, for the first time, they had the actual rock in hand, and the rock agreed. The imbalance was real. The moon has two faces, not just in appearance, but in its very bones. So the question sharpens into something almost menacing. What could possibly make one half of an entire world run colder than the other? Worlds don't just decide to be asymmetric. Something had to do this. And here is where the leading explanation gets genuinely cinematic, because it points back to that colossal scar on the far side. One of the strongest theories is that an ancient, catastrophic impact, an asteroid or even a small planetary body slamming into the far side in the moon's violent youth, didn't just carve out that 2,000-kilometer basin. It shook the entire moon's interior, redistributing the elements that generate heat, sloshing the radioactive, heat-producing materials over toward the near side, and leaving the far side depleted and cold. If that's true, then the reason the near side glows with ancient lava flows and the far side sits rugged and dead is a single act of cosmic violence, frozen into the moon's structure for 4 billion years. But, and here is the part the confident headlines skip, that is not the only explanation, and the scientists themselves are careful to say so. Another theory proposes something even stranger, that Earth may have once had 2 moons. In this scenario, a second, smaller moon collided with our moon in a slow-motion cosmic merger early in the solar system's history. And the far side and near side we see today are the fused remnants of 2 thermally different bodies. The far side would be cool because it was literally born from a different, colder moon. And a third possibility puts the blame on us, on Earth itself, suggesting that the constant gravitational tug of our planet kept the near side hotter over billions of years while the shielded far side slowly cooled. 3 theories, 1 cold hemisphere, and no consensus on which one is true. That is the uncomfortable truth beneath the breakthrough, and it's the part worth sitting with. The AI and the samples didn't close the case, they cracked it open wider. We now know for certain that the two-faced moon is real, that the asymmetry goes deep, that the far side is chemically and thermally its own world, but knowing that it's true only makes the cause more urgent to find. We've spent 65 years not knowing what the far side looked like. Now we know what it's made of, and the question has evolved into something bigger. What happened to the moon in its first 100 million years that split it into 2 different worlds, and what does that tell us about how planets, including our own, are actually built? And there's a reason that last question isn't just academic curiosity, and this is where the stakes climb again. The far side, precisely because it was so geologically quiet, may be the best preserved record of the early solar system that exists, anywhere within reach of humanity. The near side kept resurfacing itself with lava, erasing its ancient history under fresh rock. The far side didn't. Its battered, unerupted, deep frozen crust is a time capsule, a surface that has been recording the bombardment history of the inner solar system since almost the beginning, undisturbed. That South Pole Aitken Basin may have excavated material from deep inside the moon's mantle, material that could tell us how the moon formed and, by extension, how the violent early Earth-Moon system came to be. The far side isn't just a mystery, it's an archive. And we've only just learned how to read the first page, which raises the question that turns this from a science story into a geopolitical one, and you should understand why the timing is not an accident. The samples that made all of this possible didn't come from NASA. They came from China's Chang'e program, a mission that succeeded at something no other nation had ever managed, landing on the far side and returning its treasure. Whoever holds the physical material of the far side holds the ground truth that every AI model, every future map, every scientific claim about that hemisphere must be trained against and measured by. Data is one thing, but the actual rock, the calibrated laboratory-verified fingerprint of the moon's hidden half, is a strategic asset. And right now, that asset sits in one country's laboratories, while the rest of the world races to catch up. Because this is no longer just about curiosity. The far side is becoming real estate. Its permanently shadowed craters near the South Pole may hold water ice, the single most valuable resource in space, the raw material for drinking water, breathable oxygen, and rocket fuel that could turn the moon into a staging ground for everything beyond it. Its radio silence, shielded from Earth's endless electromagnetic noise, makes it the most coveted location in the solar system for the kind of deep space observatories that could hear the faintest signals from the early universe. The nation that understands the far side's chemistry, its resources, its structure, gains a head start on claiming the most important ground off-world. And the tool that just gave humanity its first real read of that ground was artificial intelligence. So consider what actually just happened here, stripped of the hype and stated plainly, because the plain version is more remarkable than any exaggeration. A machine was handed the first physical evidence ever collected from a hemisphere no human had studied. It learned that hemispheres hidden chemistry from a few kilograms of rock, and then it read that chemistry across an entire face of another world, revealing that the moon we thought we knew has been leading a double life this entire time. Cold on one side, hot on the other, two worlds fused into one, carrying the frozen memory of some ancient catastrophe we still cannot name. This is what it looks like when AI stops answering our questions and starts finding the questions we didn't know to ask. And the machine's map is not the end of this. It's the calibration point for everything coming next. More far-side missions are already being planned. More samples will come from more locations, and each one will feed the models, sharpen the maps, and test the theories against fresh ground truth. Every new sample is a new page in that 4 billion year archive, and with each one, the AI reading the far side gets better. Until, sometime in the coming years, we may finally have enough of the moon's hidden half decoded to settle the argument once and for all. Was it a monster impact? A collision between two moons? The slow pull of Earth's gravity across the eons? One of those answers is written into the far side's rocks right now, waiting. But here is the thought that should stay with you long after this ends, and it's the one nobody in the headlines wants to say out loud. Every single conclusion drawn about the far side so far rests on samples from essentially one spot inside one basin, a keyhole view of a hemisphere the size of a continent. The AI extended that keyhole into a map, brilliantly, but it extended it from a single ground truth. What if the next sample from the next landing site tells a different story? What if the far side is even stranger, even more divided, even more alien than the two-faced model we've just confirmed? We spent 65 years assuming the far side mirrored the near side, and we were catastrophically wrong. What else are we still assuming? Because the deeper lesson of this whole episode is not really about the moon at all. It's about how little we actually know about the worlds sitting right next to us, and how much of what we call settled science is built on a handful of samples and a mountain of inference. For the entire history of astronomy, half of the moon was a guess. Then a probe brought back 2 kilograms of rock, and a machine read a hemisphere, and overnight the story changed. If that's true for the moon, the most studied object in our sky, the one we've watched every night for the whole of human existence, then what does that say about Mars? About the asteroids? About the icy moons of Jupiter and Saturn where we've never landed at all? How many other two-faced worlds are out there, hiding their other half from us, waiting for a machine patient enough to read them? The far side of the moon kept it secret for 4.5 billion years. It kept it through the rise and fall of every empire in human history. It kept it through the entire space race, through Apollo, through every telescope ever pointed at the sky. And then, in a single mission and a single training run, an artificial intelligence learned to read a face humanity had never seen, and told us the moon has been living a double life all along. So the real question isn't what the machine found on the far side of the moon. The real question is this. Now that we've built something that can read the hidden halves of other worlds, what happens when we point it at the ones we're truly afraid to understand? And what will it tell us that we're not ready to hear?